So this is actually something you've already seen. It's a handler that receives HTTP requests and builds HTTP responses. Earlier, we saw one of these in the context of XSS, where the user submits some request. We build a response based on what the request was, and then we send a customized response back to the user. Now we're going to see the exact same thing, but instead of in the context of XSS, we will see it in the context of SQL injection. So in particular, once again, it's not a Golang class, so we don't care about the exact syntax. But it seems like what this code is doing is it is extracting a request from the user. So somewhere in the request, the user requested an item that they want. And then, instead of directly returning the item back to them or saying hello, like the previous example, we will actually go into a database. And we will ask the database to select the name and the price from a table where the name is equal to the item that the user asked for. So this is some sort of SQL lookup where the user asks for an item, and we will return the price of that item based on what they searched for. And then eventually, we will take that price, we will format it and make it look nice and return it to the user. So if this was some shopping website, this might be what the code is doing. The user asks for an item, we do a database lookup, and then we return whatever the database returned back to the user. So an example of how you might use this without attacks might be something like this. You go to a website with the path get items, and then with the question mark, you pass in URL parameters, and you say item equals matcha. OK. So then what the query does is, well, it still says select item price from the table where name equals. And what the name is what the user specified, which in this case would be the string matcha in red. And this would hopefully turn up some item and some price, and that would get returned to the user in the HTTP response. But now we can start thinking maliciously. What if the user didn't just put the name of the item that they want here? So what if we put something different? And it's kind of like what we did with XSS, where the user's provided input is not just some string, but it's something that's treated like code. So maybe, what if the user decided, I'm going to insert an item name that's not just a string, but it's actually just a single quote character. So the item I want is quote. Maybe this will correspond to the user going to the website, typing in a single quote, and then pressing enter to trigger this request. So now the resulting query would still be select item price from the table where name equals, and whatever goes in this blank is what the user entered, which is a single quote. Now, if you try to read this as a SQL query, you'll notice that the quotes are mismatched. This is like writing in Python or Java. If you don't have the right number of opening and closing quotes, you'll get an error. There's an opening quote, there's a closing quote, and then there's this weird unmatched third quote. So when SQL sees this query, it will say, error, I cannot complete the query. Now that's kind of weird. We weren't supposed to get an error or a SQL syntax error, but the user providing a single quote triggered an error. So what if we get even more malicious than this? What if we type in something weird like this, quote or 1 equals 1? What does that do? Well, once again, we take the original query, and all we do is we take the space between the two quotes, and we substitute in exactly what the user typed with no modifications at all. So if the user typed this weird string, we'll take that exact same string and plug it into the query. And then we'll pass this query to the SQL interpreter. And what will the SQL interpreter read? It will say, I still want the items and the prices from the table. And then the where clause says, here's the conditions that need to be true for the rows to be returned. And it says, either name is blank. So if any of the rows have a blank name, that will be returned. Or 1 equals 1. That's another condition for when the row is returned. Now, when is 1 equal to 1? Always. That's a fact that's always true. So what will happen is we'll go to each row one by one, and we'll say for the first row, is 1 equal to 1? Yes. So we'll return that row. For the second row, is 1 equal to 1? Still true, so I'll return that row as well. And what this query ends up doing is it returns the entire table with all of the items and prices. Now, that's not something we were supposed to allow the user to do. They were supposed to search for an item and get the corresponding price. But here, we have allowed the user to leak the entire table of items and prices, including maybe hidden items that were not supposed to be seen, by providing an input like this, which causes this entire where clause, instead of filtering for name, to filter on everything. That is, it returns true, so every row gets returned. Now, what if we're even more malicious? What if we type something like quote, semicolon, drop table items, dash, dash? So once again, SQL doesn't do anything interesting. It takes the user input, directly copies it into the query, and then runs this query. So once again, we can try to read this query. What does it say? Select the item and the price from the table where name equals blank. So I'd go through and I'd pick out all of the rows where name equals blank and return them. And the semicolon says, that's the end of this statement. Now that wasn't so interesting. But what is interesting is this second part where we say drop table items. Because we remember our SQL syntax. This says delete the entire items table. So this attacker has successfully caused the server to delete its entire table, even though that was not the intention of this website. So we've let the attacker delete the table. Now, you might be wondering what these two dash dashes are and why the query only works with this dash dash. If we don't have the dash dash, then what would the SQL interpreter do? It would look at this query, and it would notice mismatched quotes. Here's an opening quote. Here's an ending quote. So what's that one all about? That's a mismatched number of quotes, and you would get an error. The table might not get dropped. So if we didn't have the two dashes, this would be a mismatched quote. However, remember the two dashes in SQL stand for comment. So what you've basically done is you've said everything after the two dashes is a comment. Please don't use it as code. And so this quote at the end is now considered a comment, and it doesn't affect our query. That's why the two dashes are there. And in case you're wondering, how were there three quotes to begin with? Remember, the two quotes in black on either end, those were there from the query to begin with, where name equals quote, whatever the user wrote, and then another quote. So the opening and ending quotes come from the user query, and then all of this stuff in red, including a third quote, comes from the attacker. So once again, all you're doing is just substituting in what the user requested into the query, reading it like SQL, and executing it. This attack is called SQL injection.